Okay, let's do Unit 4A, Day 3A, basic trigonometric, if I can say that right, identities. So today we're going to look at some coterminal angles. We're going to look at a Pythagorean identity, and then on the back we're going to look at some other identities that it's nice to, if you can memorize them, that's great. I really would rather you understand them more than memorize them, because if you understand them, you don't have to memorize them. You can rediscover it yourself every time if you truly understand it. So first off, up here it says same angles with different measures are called coterminal angles. So if they end up having the same landing place on the unit circle or the Cartesian plane or whatever you want to call it, if they have the same landing spot but different number values, they are considered coterminal angles. Okay, so coterminal angles have the same initial and terminal sides but are named differently. So down below, we're supposed to draw the given angle in standard position, given angle that would be a coterminal with that. So 210 degrees, first off, this would be 180, and then to get to 210, you have to do a 30 more. So this is just 30 degrees more. I'm kind of putting that down to remember that. So this is 210 degrees. A coterminal angle, instead of going this way, I could go this way, 150. So negative 150 would be considered a coterminal angle with that. Yeah, so that's probably good enough. So these two would be the same. Now, I could go even crazier with this. I could say 210. I could go a full circle and then come around. So it'd be 360 plus 210, which is what, 570? So 570 would be a coterminal angle. And you can probably see that this would never end. I mean, I could just write an infinite amount of coterminal angles, depending on how many times I wrap around the origin there. So the general form for this would be any number that would be 210 plus a full circle, 360, however many times. I'll just put an n there. Now I could go 360 forward. I could go 360 backwards. It doesn't matter how many times. So n could be a whole number, 1, 2, 3, 4, 5 times, but it could be negative also. It could be 0. If I put a 0 in for this, that would just be 210, which is the original value. If I put a negative 1 in here, that means go backwards, which is actually where the negative 150 comes from. Take 210 minus 360, you get negative 150. So as long as n, and I'm just going to use this notation, so this symbol just means within the subgroup, within the group of, and then I want integers. So as long as I multiply 360 by an integer and then add 210, I will get another coterminal angle. So instead of trying to list all the infinite coterminal angles, I'm just going to put it in general form, how you find all of them. Now the symbol for integers, you could just write integers here, int or whatever. I'm just going to be lazy. It's this right here, this z. Z represents integers. Why? I have no idea. I probably could Google that and find out why do they use the letter z to represent integers. Why not the letter I? But that's just, so if you get a number theory course, z is integers. So just introducing you to that right now. Now the reference angle for this is just how far away from the x-axis. So this is 30 degrees away, so the reference angle here is 30 degrees. Now I got 5 pi over 4. 5 pi over 4, if you just need a quick idea of where that even lands, remember, if I plug in 180 for pi, that's like the quick way of converting to degrees. So if you take 5 times 180 divided by 4, you get 225. Well, 225 is more than 180, but less than 270, so it's somewhere in this third quadrant. If I subtract 180 from that, I actually get 45, so that means it's a 45-degree angle in here. So 45 degrees past the x-axis. So there would be 5 pi over 4. So coterminal with that, instead of going 5/4 this way, and remember 2 pi is a full circle, I could say 2 pi minus 5/4, I get negative 3 pi over 4. So that would be, so instead of going this way, 5 pi over 4, I could go this way, negative 3 pi over 4. And then if you want to wrap stuff around here, I could do 5 pi over 4 So 5 pi over 4 plus a full circle, which would be 2 pi. So 5 pi over 4, and so 5 pi over 4 plus 2 pi would be the same thing as 8 pi over 4. So if you want to put common denominators, it's the same thing as 2 pi. So it'd be 13 pi over 4. And we could just keep doing this over and over. So the general form for this, if I want to find any coterminal angle, it'd be 5 pi over 4 plus any number of circles, any number of 2 pi's. So I'm going to put an n there, where n is in the integers. So same idea. It's just how many times did you wrap around before you landed on 45 degrees past the x-axis. That's up to you, but how many times you go. But any number of circles plus 5 pi over 4 will land in the exact same spot as this one. Now the reference angle for that, 45 degrees. Okay. Negative 2 thirds pi. Again, 1 pi would be this way. This is half a pi, so it's somewhere between there. You know, I went clockwise. It's somewhere in here. Ends up, if you do a little bit of work, it's 60 degrees short of the x-axis, or 30 degrees past straight down, however you look at it. So this one, coterminal, whoops, so we already got. So this is negative 2 pi over 3. If I want to go the other way, take 2 pi minus 2 thirds pi, and you get 4 thirds pi. So 4 thirds pi, you could wrap 4 thirds plus 2 pi. So 4 thirds pi plus 2 pi, which would be 6 pi over 3. So that'd be 10 pi over 3, and you could just keep doing that over and over. So now instead of writing all of them, I'm just going to write the general form. Well, the general form, and you could start with negative 2 pi over 3. That'd be fine. I'm actually going to start with 4 pi over 3 plus 2 pi n. But you could put negative 2 thirds pi plus 2 pi n. It's fine. And there's not one specific right answer here, but typically we like the positive one, given that n is in the integers. And then the reference angle for this, again, it was 60 degrees short of the x-axis, so this would be a 60-degree reference angle. And that reference angle is just like if it makes a triangle and you would do sine, cosine, tangent, you would do with respect to the x-axis, because the coordinates, how far left and down you go, that's this angle inside here. Okay, so just in general, if we're trying to write coterminal angles, if it's in degrees, whatever degree you were given, plus 360 times n, where n is in the integers, that's going to give you your answer for the general form. Coterminal angles in radians, going to be whatever angle you were given, plus 2 pi n, as long as n is in the integers. Okay, now some trig identities we'll use, and this one's the easiest one. I think this one's the most straightforward, and probably even when you get the AP test, I think it's probably the one used most too, because there are sometimes on the AP test, the AP Calc test, that you need to know trig identities, and the Pythagorean identity is probably the easiest one. It's one you're most familiar with. So if you look at this guy right here, if you know the x is the cosine and the y is the sine, if you look at the coordinates of this point, well, that would be the same thing as this x and this y, the sides of the triangle. And if it's a unit circle, this is always 1. The hypotenuse is 1. That's a right triangle, use Pythagorean theorem. So we would say x squared plus y squared equals 1 squared. Well, I don't need to put the 1 squared, then I could say 1 squared, but 1 squared is 1. Now, x is the same thing as cosine. So this is the same thing as cosine squared. And this is the cosine ratio squared, not x being squared. Okay, so this is very different than this. This would mean whatever x value I give you, like if I said the cosine of 30 squared, you take 30 squared first, give me 900, then take the cosine of 900. On this one, I would take the cosine of 30, get that ratio, and then I would square that ratio. So those are very different things. And so if you want to, instead of putting parentheses on like this on the outside, they just put it squared right there. And then the y is the same thing as sine, so the sine ratio, the entire thing squared, will equal 1, and that is the Pythagorean identity. And so down here, I'll give you some examples. Maybe this will just sort of cement that whole thing in there. I'll do it the old way and I'll do it the new way. So it says, given that the sine of theta, it's supposed to be theta, it's a terrible symbol. I'm not sure why when I printed it did that, but given that the sine ratio is -8/17, find the cosine and the tangent ratios. So the old way for this one, and it says that theta is in the third quadrant, the old way would be, I'll draw in the middle here. If it's in the third quadrant, that means the hypotenuse is 17, and the sine ratio, remember sine tells you how far down you went, that's the y-coordinate. So this, I could say that this is -8, and then use Pythagorean theorem to find this side. So 17 squared minus 8 squared to the square root would be 15. I know that since I went to the left, it's -15. And then I could write, I could find my cosine. Cosine would be adjacent of hypotenuse, so -15/17. And then the tangent would be opposite over adjacent, so that would be -8 over -15, or just 8/15. Now this new way, if you're using this Pythagorean identity here, if I know the sine and I'm trying to find the cosine, I could just use, it's almost like you're thinking of it as a unit circle instead. So think of this as 1 unit, and this is -8/17 down. Okay, so if I'm trying to find that side, I could use Pythagorean theorem, and my answer of that is what cosine is. So if you use Pythagorean theorem, -8/17 squared plus cosine squared equals 1. So it's going to be 1 minus -8/17 squared. Type it in your calculator. In fact, if I do this, it'll give me some decimals. So I'll take 1 minus, and in the parentheses, I don't really need the negative because my square is going away anyway. I get this decimal. And remember, if you push math and number 1, fraction, let's convert it back to a fraction for me. Oops, I forgot the square root. So square root of this answer. So it's 15/17, which is what we thought it was going to be, 15/17. Now, I would have to know that because this was negative, that had to be negative, since the third quadrant here. So I would have to account for that. When I solve for theta, I'd get 15/17, but I have to realize it's negative, so it'd be like this. And then if you want to find the tangent ratio, or sine over cosine, so 8/17 over 15/17, and negatives would wipe out, 17s would wipe out, and it'd just be 8/15. There's your tangent. So 2 different ways to, quote unquote, skin a cat on that one. So if I wanted to do this a little quicker, if the cosine is 0.6 and I want to find the sine, well, cosine squared plus sine squared theta equals 1. So it'd be 0.6 squared plus sine squared equals 1. So my calculator, I could take 1 minus 0.6 squared, take the square root, I get 0.8, so that means it should be cosine sine theta equals 0.8. So then if I want to find the tangent ratio, it would just be sine over cosine. So 0.8 over 0.6, and that would be 4/3 if I do some reducing, so that equals the tangent. I just did the whole thing without drawing a triangle. One thing I should keep in mind, I didn't mention this, so the cosine ratio is positive, and it's in the fourth quadrant, so that means I went right and then down if it's in the fourth quadrant. So the cosine is your x, that's positive. The sine has to be negative, so this has to be negative. And if the sine's negative, then the tangent is also negative. So I forgot to put that negative in there. That's the only bad thing about it is you have to keep in mind, what quadrant you're in, what's the sign on it. So let's see here. So now flipping the paper over, and it should be, this should be written down here. So let's do this. For some reason, when I hit print, it got moved up to the page before it, so that's okay. Now, find the sine of 30. Okay, so the sine of 30, that's in the first quadrant. And it's a 30, 60, 90 triangle. So if this is 1, that's a half. This is radical 3 over 2. Adjacent over hypotenuse, that'd be radical 3 over 2. Now find the sine. Opposite over adjacent, that's a 1/2 over 1. The tangent then would be 1/2 over radical 3 over 2. So that I could wipe out the 2 to be 1 over radical 3. Or you could look back at here and do something with that if you want. And then radical 3 over 3 would be the final answer. Now, what if I did the opposite of the angle itself? Okay, so instead of going up 30 degrees, it's going to go down 30 degrees. Now, the ratios are the same. This is going to be negative 1/2. This is going to be 1, and this is still going to be radical 3 over 2. So instead of going up, it flipped about the x-axis. Now it's going down. Well, if it flips about the x-axis, your x-coordinate didn't change. You still went right. It's just now you're going to go, instead of going right and up, you're going to go right and down. And since the cosine represents the x-coordinate, you're still going the same amount to the right. You're still going radical 3 over 2 to the right. It's just now you're going to go down 1/2. So the sine will change, but the cosine will not. Now, because tangent is the ratio of sine over cosine, if this goes negative and that one stays positive, this one's going to be negative. So this will be a negative radical 3 over 3. If you want to check that, go ahead and do all the ratios. It comes out to be that way. So this is the opposites theorem. It says if you took the opposite of the angle, the cosine ratio is actually going to stay the same. Because when you take the opposite of the angle, you're, instead of opening clockwise, you're opening counterclockwise. You're still going to go right or left the same amount you did before. You're just going to go up instead of down or down instead of up. So this stays the same. This actually goes the opposite. Okay? And if one of them goes opposite and one doesn't, because tangent is sine over cosine, if one's negative and one's not, then it's going to be opposite. So for opposites, putting a negative in there, it changes sine, changes tangent, it doesn't change cosine. So cosine stays unaffected for that reason, that you're still going to the right or to the left. If you originally went left on the angle, you're still going to go left. It's just, instead of being this way, it's going to be this way. So it gets flipped about the x-axis. Now, if I have the cosine of 30 plus 180, think about adding 180 does what to an angle? So if I was originally, where do I want to draw this at? I'll draw it over here. So if I was originally opening 30 degrees this way, if I add 180 to that, that's going to take it down this. It's going to flip it about the x-axis, and I'm going to be going that way. So if I went right and up, the sine and cosine, they were both positive. Now if I add 180, it's actually going to be left and down because it flipped this way. So that means the cosine and the sine of both will actually switch. So if I add 180, the cosine will become negative, the sine will become negative. Okay? If they both go negative, what happens to the tangent? Well, the tangent is sine over cosine. If they're both negative, that means it actually stays the same. So it's in your mind, think about what does adding 180 do? It takes it from here down to here. So instead of going right and up, you're going to go left and down. If I originally went left and up, now I'm going to go right and down. So they both switched. The cosine and sine ratios, the x and y coordinates, both switched. So they're both negative. Tangent is unaffected because it's a ratio of negative or negative. 180 minus 30. Well, if I was at 30, and now I take 180 minus 30, that's 150. Now I'm going to be going this way instead. That's a reflection about the y-axis. Okay, so this up here, this is like a reflection about the x. This is a reflection about the x and y. And then this one down here, when you take 180 minus the angle, that's just a reflection about the y-axis. So if I reflect about the y-axis, the x-coordinate was positive, now it's negative. So the cosine will be switched, because cosine represents the x value. Sine represents the y value. If y was positive, y is going to stay positive. If y was negative to begin with, it's going to stay negative. So the sine doesn't change. Okay, so taking 180 minus an angle is the same thing as sine of that angle. It really doesn't affect it at all. When I'm trying to find tangent, look at this ratio. Positive or negative is negative, so it'll be a negative tangent. So anywhere you see this, you could replace it with that. Okay. And then complements of this guy. If you remember a couple of days ago, we talked about how the sine of one angle will be equal to the cosine of the other non-right angle. Okay, so like if I have, I'm going to draw a diagram here. So I got this guy here, and if I did the sine of this W, sine would be opposite over hypotenuse, which is z over x. I'm sorry, I said that backwards. X over z. So the sine opposite over hypotenuse. Well, that'd be the same thing as the cosine of theta, because the cosine of theta is adjacent over hypotenuse, x over z. Or if I did the cosine of W, that'd be y over z. Well, that's going to equal the same thing as the sine of theta. Sine would be y over z, opposite over hypotenuse. So, and on this one, the relationship between the theta and the W, which I think it's might be omega, can't remember. But the different, how these two are related is they have to add up to be 90. If this is 90 degrees, there's 90 left for that. So if I know W and want to find theta, I take 90 minus W and I'll get theta. Or 90 minus theta equals W. So in here, when I have cosine of 90 minus theta, it's the same thing as sine of, 90 minus theta, that's like W. 90 minus theta is W, so the cosine of W equals the sine of theta. 90 minus theta is the same thing as W, so sine of W is the same thing as cosine of theta. Okay, so there's really nothing right. Those are the what equals. I filled it out for you. Okay, so below, look at what property above am I referencing here. So I'm talking about the sine ratio. So keep in mind that sine represents y values, the y coordinate. If I took the angle plus 180, that means I'm flipping it about the x and y axis. So if I flip it about the x and y axis, that means the y is going to change. It's going to be the opposite. Okay, so if the sine of x was 2/9, well, when I flip it about the x and y axis, the y ratio is going to change. It's going to be negative 2/9. This one here, and I made a mistake, so I cut my video here. So if this sine ratio is 2/9, that means opposite over hypotenuse was 2:9 ratio. If I add 180, that means it's going to open this way, and the hypotenuse is still 9, but now it's going to be down 2. So the ratios opposite over hypotenuse would be a negative 2/9. Okay, cosine. Think cosine represents the x's. If I add 180 degrees, that means it's going to flip about the x and the y axis. So if it's going to flip about the x and y axis, the x gets the opposite. So this would be negative cosine of whatever x was. Well, I need to go back and figure out what was negative cosine. So if this was 9 and that was 2, 9 squared minus 2 squared is radical 77. So that'd be adjacent over hypotenuse. So it's going to be a negative radical 77 over 9. Because the cosine of the original cosine ratio was radical 77 over 9. When I added 180, it became negative. Here's sine. Remember, sine represents the y value. So in my mind, I'm thinking how far up or down I go. If I had the exact opposite value, that's going to flip it about the y-axis. So that's this guy. Actually, I'm sorry here. I'm not mixing myself up. This is the first guy. It's going to flip about the x-axis. This is the one where instead of opening up, instead of opening this way, I would open that way. I'd open down. So how far to the right I go would stay the same. How far up or down I go would be the opposite. So if it's a y value, instead of going up, I'm going down, or instead of going up, I'm going, what did I just say? Instead of going down, I'm going up. So instead of being 2/9, now it would be negative 2/9. Now the cosine of x, now I already found that. The cosine of x here would be radical 77 over 9. I guess I should have found that first. And then the cosine of 90 minus, so this is a complement idea. So the complement cosine of 90 minus x would be the same thing as sine of x. Because 90 minus x is the other angle that we're talking about. Well, sine of x is 2/9 on this one. Okay? So like I said, try to make sense of it. Like does this adjustment make it flip about the x-axis, about the y-axis, about both? Which one does it do, rather than trying to memorize all these? I think you're going to forget and make mistakes if you just strictly try to memorize.